So very quickly in this video, I'm going to show you how to calculate the molar mass of a compound, specifically the compound potassium dichromate. And so the molar mass of a compound is just all of the molar masses of the individual atoms added up together. So for potassium dichromate, the formula is K2Cr2O7. So the molar mass of this compound is going to be the atomic mass of potassium, of chromium, and oxygen, all added together. And you know you can get the atomic mass of each of your individual atoms from your periodic table. These are values that are always available or should be always available to you, and you just have to refer to them to figure out, okay, so the atomic mass of potassium is 39.01, of chromium it's 51.9961. You can round that number to like 52, and oxygen is 16. So these values in a question like this would always be given to you, or you would just be given the periodic table and be expected to be able to read these numbers off of the table. So coming back to the question, we have our potassium dichromate. So I'm just going to start setting up the problem like this. So we'll first look at all the atoms we have. So we have potassium, chromium, and oxygen in this compound. Then we don't only have one of each, these subscripts. They're telling us that we have two potassiums, 2 chromiums, and 7 oxygens. So we have to take that into consideration as well. So, but before that, let's just note down the atomic mass of each of the individual atoms. So we saw from the periodic table, potassium was 39.01, 39.1, chromium was 52, just round that 52.0, and then oxygen was 16.0. So we have our atomic mass, and now we have to, of each of the atoms, now we have to take in the number of each atom present in the compound into account. So for potassium, we have 2 potassiums. Again, we get that from the subscripts that is directly in front of the atom. And for chromium, we have 2 chromium, again, right from the subscript. And then oxygen, we have 7 oxygens. So we have the atomic mass of each of the individual atoms. We have the number of each of the individual atoms, so we can calculate the total mass of each atom in this compound. So for potassium, we have 2 potassiums, so 2 times 39.1 would give you 78.2, and the unit is grams per mole here. And then for chromium, also we have 2 chromiums. 1 chromium has the atomic mass of 52, so 2 chromiums would have the atomic mass of 52 times 2, which is 104 grams per mole. And then oxygen, 1 oxygen has the atomic mass of 16, so 7 oxygens will have a total mass of 16 times 7, which is 112 grams per mole. So now, to finally get the molar mass of a compound with 2 potassiums, 2 chromiums, and 7 oxygens, you just add up these values, the total mass of each of your individual atoms. And that comes out to be 294.2 grams per mole. And that is it.